Good day everyone, we are the group 4 and we're here today to discuss about evaporation. So, what is evaporation? Evaporation is a type of vaporization that occurs on the surface of the liquid as it changes into the gas phase. It is the primary pathway that water moves from the liquid state back into the water cycle as atmospheric water vapor. It occurs when some water molecules attain sufficient kinetic energy to break through the water surface and escape into the atmosphere. Approximately 600 calories needed to evaporate 1 gram of water. It depends on the supply of heat energy and the vapor pressure gradient, which in turn depends on water and air temperature, wind, atmospheric pressure, solar radiation, and etc. When evaporation occurs, the energy removed from the vaporized liquid will reduce the temperature of the liquid, resulting in evaporative cooling. Evaporation is an also essential part of the water cycle. The sun, solar energy drives evaporation of water from oceans, lakes, moisture in the soil, and other sources of water. In hydrology, evaporation and transpiration, which involves evaporation within plants' stomata, are collectively termed evapotranspiration. Evaporation of water occurs when the surface of the liquid is exposed, allowing molecules to escape and form water vapor. This vapor can then rise up and form clouds. With sufficient energy, the liquid will turn into vapor. So, Lesson 2, the process of evaporation. Evaporation happens when a liquid substance becomes a gas. When water is heated, it evaporates. The molecules move and vibrate so quickly that they escape into the atmosphere as molecules of water vapor. Evaporation is a very important part of the water cycle. Heat from the sun or solar energy powers the evaporation process. It soaks up moisture from the soil in a garden, as well as the biggest ocean and lake. The water level will decrease as it is exposed to the heat of the sun. Although the level of a lake, pool, or glass of water will decrease due to evaporation, the escaped water molecules don't disappear. They stay in the atmosphere, affecting humidity or the amount of moisture in the air. Areas with high temperature and large body of water, such as tropical islands and swamp, are usually very humid for this reason. Water is evaporating but staying in the air as a vapor. Once water evaporates, it also helps form clouds. The clouds then release the moisture as rain or snow. The liquid water falls to the earth where it will evaporate. Then the cycle starts all over again. Many factors affect how evaporation happens. If the air is already clogged or saturated with other substances, there won't be enough room in the air for the liquid to evaporate quickly. When the humidity is 100%, the air is saturated with water. Then no more water can evaporate. Air pressure also affects evaporation. If air pressure is high on the surface of a body of water, then the water will not evaporate easily. The pressure pushing down on the water makes it difficult for the water to escape into the atmosphere as vapor. Storms are often high-pressure systems that prevents evaporation. Temperature, of course, affects how quickly evaporation happens. Boiling hot water will evaporate quickly as steam. Evaporation is the opposite of condensation, the process of water vapor turning into liquid water. So, here is the example of boiling water evaporates into thin air. So, factors influencing the rate of evaporation. In factors influencing the rate of evaporation, we have 7 factors. The first one is the concentration of substances evaporating in the air. If the air already has a high concentration of the substance evaporating, then the given substance will evaporate more slowly. So if the air is already saturated with other substances, it can have lower capacity for the substance to evaporating. So the second one is the flow rate of air. This in part related to the concentration above. If fresh air is moving over the substance all the time, then the concentration of the substance in the air is likely go up with the time, thus encouraging faster evaporation. This is the result of the boundary layer at the evaporation surface decreases the flow velocity, decreasing the diffusion distance in the stagnant layer. So, the molecules in motion have more energy than those at rest. And so, the stronger the flow rate, the greater the evaporating power of air molecules. So, the third one is the intermolecular forces. The stronger the forces keeping the molecules together in the liquid state or solid state, the more energy that must be input in order to evaporate them. As we see in the picture, in intermolecular forces, for molecules at the surface, there are no upward forces, so the molecules are closer together. Also, for the molecules in the center of the liquid, the intermolecular forces act in all directions. The fourth one is the pressure. In pressure, evaporation happens faster if there is less exertion on the surface, keeping the molecules from launching themselves. The fifth one is the surface area. It is a substance that has a larger surface area will evaporate faster, as there are more surface molecules per unit of volume that are potentially able to escape. Since evaporation is a surface phenomenon, the greater the surface area occupied by the liquid, the quicker it undergoes evaporation. And the last one is the temperature of the substance. The higher the temperature of the substance, the greater the kinetic energy of the molecules at its surface, and therefore the faster the rate of their evaporation. So, the greater the temperature of the liquid and its surrounding, the faster the rate of evaporation.
So, lesson 3. Estimation of evaporation. Estimation of evaporation is done by the following methods. First one, using evaporimeters. Second, using empirical equations. And lastly, by analytical methods. So, I'll be reporting the estimation of evaporation using evaporimeters. Evaporimeter. These are pans containing water which are exposed to the atmosphere. Loss of water by evaporation from these pans are measured at regular intervals or daily. Meteorological data such as humidity, wind velocity, air and water temperatures, and precipitation are also measured and noted along with evaporation. So this instrument is usually called as atmometer, an instrument used for measuring the rate of water evaporation from wet surface to the atmosphere. This instrument also is mainly used by farmers and growers to measure the evapotranspiration rate of crops at any field location. The first type of evaporimeter is the USWB Class A evaporation pan. This pan is the most commonly used type of pan in the world. This pan has a diameter of 1,210 mm and depth of 255 mm. Depth of water is maintained between 18 and 20 cm. The pan is made of unpainted GI sheet, and the pan is placed on a wooden platform of height 15 cm above ground level to allow free air circulation below the pan. Evaporation is measured by measuring the depth of water in a sealing well with a loop gauge. Okay. So this is what a USWB Class A looks like. Okay. So next type is the ISI standard pan. It is specified by IS 5973 and known as the modified Class A pan. A pan of diameter 1,220 mm and depth of 255 mm. This pan is made of copper sheet of 0.9 mm thick, tinned inside and painted white outside. The pan is placed on a square wooden platform of width of 1,225 mm and height of 100 mm above ground level to allow free air circulation below the pan. A fixed point gauge indicates the level of water. Water is added to or remove from the pan to maintain the water level at a fixed mark using calibrated cylindrical measure. The top of the pan is covered with a hexagonal wire net of GI to protect water in the pan from birds. Presence of the wire mesh makes the temperature of water more uniform during the day and night. Evaporation from this pan is about 14% lower as compared to that from an unscreened pan. So this is what an ISI standard pan looks like. So here is the stealing well, okay, and the fixed point gauge. And also pala, ISI stands for Indian Standards Institute. 3. Colorado sunken pan, a 920mm square pan made of unpainted GI sheet for 60mm deep and burrowed into the ground within 100mm of the top. Main advantage of this pan is that its aerodynamic and radiation characteristics are similar to that of a lake. Disadvantages is that it is difficult to detect leaks, expensive to install, extra care is needed to keep the surrounding area free from tall grass, dust, etc. One thing to point out in this type of evaporimeter is that this type is buried. This is what a Colorado sunken pan looks like. Okay. So for the last type of evaporimeter is the US Geologic Survey floating pan. Square pan of 900mm side and 450mm deep, supported by drum floats in the middle of a raft size 4.25 meters by 4.87 meters. It is set afloat in a lake with a view to stimulate the characteristics of a large body of water. Water level in the pan is maintained at the same level as that in a lake, leaving a rim of 75mm. Diagonal baffles are provided in the pan to reduce surging in the pan due to wave action. Disadvantages is that high cost of installation and maintenance, difficulty in making measurements. Unlike the other types mentioned earlier, this type of pan is floating. Okay, this is what a USGS floating pan looks like. Okay. Pan coefficient. Evaporation pans are not exact models of large reservoir. This is true kasi this is mainly a representation lang of a wet surface. So their major drawbacks are the following. First one is they differ from reservoir in the heat surface, seat storage capacity, and heat transfer characteristics from the sides and the bottom. From sunken and floating pans aim to minimize the problem. Hence, evaporation from a pan depends to some extent on its size. Evaporation from a pan about 3mm diameter is almost the same as that from a large lake, whereas that from a pan of about 1mm diameter is about 20% in excess of this. Second one is the height of the rim in an evaporation pan affects wind action over the water surface in the pan. Also, it casts a shadow of varying size on the water surface. And lastly, the heat transfer characteristic of the pan material is different from that of a reservoir. Okay. Pan coefficient is the ratio of the amount of evaporation from a large body of water to that measured in an evaporation pan. The formula for pan coefficient is here. Lake evaporation is equals to pan coefficient times pan evaporation. Hence, evaporation measured from a pan has to be corrected to get the evaporation from a large lake under identical climatic and exposure conditions. So, pan coefficient vary to any types of evaporimeter. So, for Class A land pan, the pan coefficient has an average of 0.70 and a range of 0.60 to 0.80. So for ISI pan, it has an average of 0.80 and a range of 0.65 to 1.10. For Colorado sunken pan, has an average of 0.78 and a range of 0.75 to 0.86. And lastly, for the USGS floating pan, the pan coefficient used is 0.80 and the range of 0.70 to 0.82. Evaporation pans are normally located at stations where other hydrometeorological data are collected.
Continuation of the track. Letter C. Evaporation stations. WMO recommends the following values of minimum density of evaporimeters, such as arid zones, which consist one station for every 30,000 square kilometer. Humid temperate zones, which consists one station for every 50,000 square kilometer. And the cold regions, which consist one station for every 1 million square kilometer. A typical hydrometeorological station has the following: recording rain gauge and non-recording rain gauge, Stevenson box with maximum, minimum, wet and dry bulb thermometers, also wind anemometer and wind vane, panevaporimeter and sunshine recorder, and etc. D. Empirical equations. Most of the available empirical equations for estimating lake evaporation are a Dalton type equation of the general form. So ito yung equation niya. EL equals KF times U times EW minus EA. Also, there are two types of formula, the Mayer's formula and the Rower's formula. Wind velocity. In the lower part of atmosphere, up to a height of about 500 meter above the ground level, wind velocity follows the 1/7 power law. Ito yun. UH equals CH 1/7 power law. Where UH is the wind velocity at a height above ground level, and C is constant. Letter E. Analytical methods of evaporation estimation. Ayan, tatlong methods. Number 1 is the water budget method. Pangalawa is the energy budget method, and the last one is the mass transport method. Ito yung water budget method. Yan yung which P is the daily precipitation, VIS is the daily surface inflow into the lake, VIG is the daily groundwater inflow, VOS is the daily surface outflow from the lake, VOG is the daily groundwater outflow, EL is the lake evaporation, Delta S is the increase in lake storage in a day, TL is the daily transpiration loss, and all quantities are expressed in units of volume or depth. And ayun, yung iba is can be measured, which the P, VIS, VOS, and the delta S. And yung iba naman is na-estimate lang the VIG, VOG, and PL. If the unit of time is kept very large, estimates of evaporation will be more accurate. It is the simplest of all methods but the least reliable. Number 2 is the energy budget method. It involves application of the law of conservation of energy. Energy available for evaporation is determined by considering the incoming energy, outgoing energy, and the energy stored in the water body over a known time interval. Estimation of evaporation from a lake by this method has been found to give satisfactory results, with errors of the order of 5% when applied to period less than a week. So ito yung formula niya. Hn is equals to Ha plus He plus Hg plus Hs plus Hi. This is the energy balance in a period of 1 day. All energy terms are in calories, square meter day. If time periods are short, Hs and Hi can be neglected as they are negligibly small. All terms except Ha can either be measured or evaluated indirectly. Ha is estimated using Bowen's ratio. So, yun yung formula. Yung formula ng Bowen's ratio. And last, the comparison of methods. Analytical methods can provide good results, however, they involve parameters that are difficult to assess. Empirical equations cannot best give approximate values of the correct order of magnitude. In view of the above, PAN measurements find wide acceptance in practice. So, yun ito.
Good afternoon, everyone. I am Jomari R, and I will be discussing Lesson 4, Evaporation from Different Surfaces. All liquids evaporate if exposed to certain elements. The rate at which a liquid evaporates depends on its molecular structure. The other factors that affect evaporation are surface area, temperature, and air movement. You can do a few fairly simple experiments to demonstrate the effect that the various factors have on the rate of evaporation. So yung nandito lang sa module natin is etong tatlo lang factors that affect evaporation, itong surface area, temperature, and air movement. Pero meron tayong 9. So ito yung temperature dun sa dito na sa module. Temperature, surface area of the liquid, humidity of the air, wind speed, intermolecular attraction, atmospheric pressure, depth of the body from where evaporation occurs, vapor pressure difference, and presence of solutes in solution. So meron tayong 9. So nandito lang sa modules etong tatlo. And ito yung nandito sa module. Testing the effect of surface area. Molecules contained in a liquid evaporate from the surface area. This means that the larger the surface area, the faster the rate of evaporation. Test this by putting water into two different containers. Use one that has diameter of 3 or 4 inches, such as a glass, and another that has a diameter of 8 to 10 inches, such as a bowl. Put 2 ounces of water into a measuring jug, then transfer it to the glass. Do the same for the bowl and then place the containers next to each other. This means all the other factors that affect the rate of evaporation are identical. Leave the containers for 1 hour. Pour the water from each container into the measuring jugs and write down how much water is left. The amount of water left in the bowl is much less than is left in the glass due to the difference in surface area. So next, Lesson 5. The components of evaporation from vegetation covers. Evapotranspiration is the sum of evaporation from the land surface plus transpiration from plants. If you search for the definition of evapotranspiration, you will find that it varies. In general, evapotranspiration is the sum of evaporation and transpiration. Some definitions include evaporation from surface water bodies, even in the oceans. But since we have a web page just about evaporation, our definition of evapotranspiration will not include evaporation from surface water. Here, evapotranspiration is defined as the water lost to the atmosphere from the ground surface, evaporation from the capillary fringe of the groundwater table, and the transpiration of groundwater by plants whose roots tap the capillary fringe of the groundwater table. The banner at the top of page offers an even more simple definition. The transpiration aspect of evapotranspiration is essential evaporation of water from plant leaves. Studies have revealed that transpiration accounts for about 10% of the moisture in the atmosphere, with oceans, seas, and other bodies of water, like lakes, rivers, streams, providing nearly 90% and a tiny amount coming from sublimation, like exchanging into water vapor without first becoming liquid. So, ang evaporation is transformation of liquid water to vapor. Ang transpiration naman is water vapor emission from plant surfaces or outdoor processes of water budgets. Ang evapotranspiration naman or ET is the combined process of water surface evaporation, soil moisture evaporation, and plant transpiration. So ito yung figure 7. Evaporation transpiration process credit salinity management organization. So nandyan yung precipitation, transpiration, at evaporation. Nakita natin sa picture. Figure 7 shows the typical plant, including any found in a landscape absorbs water from the soil through its roots. So, ito yung That water is then used for metabolic and psychologic functions. The water eventually is released to the atmosphere as vapor via the plant's stomata. So, ang stomata is tiny, closable, pore-like structures on the surfaces of leaves. Overall, this uptake of the water at the roots, transport of water through plant tissues, release of vapor by leaves is known as transpiration. Water also evaporates directly into the atmosphere from soil in the vicinity of the plant. Any dew or droplets of water present on the stems and leaves of the plant eventually evaporates as well. Scientists refer to the combination of evaporation and transpiration as evapotranspiration, abbreviated EP. So, ito yung sabihin ng evapotranspiration, abbreviated by EP. Transpiration, the release of water from plant leaves. Just as you release water vapor when you breathe, plants do too, although the term transpire is more appropriate than breathe. These pictures shows water vapor transpired from plant leaves after a plastic bag has been tied around the stem for about an hour. If the bag had been dropped around the soil below it too, then even more water vapor would have been released as water also evaporates from the soil. Plants put down soil into the soil to draw water and nutrients up into the stem and leaves. Some of this water return to the air by transpiration. Transpiration rates vary widely depending on weather conditions, such as temperature, humidity, sunlight availability and intensity, precipitation, soil type and saturation, wind, and land slope. During dry periods, transpiration can contribute to the loss of the moisture in the upper soil zone, which can have an effect on vegetation and food crop fields.
How much water do plants transpire? Plant transpiration is pretty much an invisible process. Since the water is evaporating from the leaf surfaces, you don't just go out and see the leaves breathing. Just because you can see the water, it doesn't mean it is not being put into the air. Though, one way to visualize transpiration is to put a plastic bag around some plant leaves. As this picture shows, transpired water will condense on the inside of the bag during a growing season. A leaf will transpire many times more water than its own weight. An acre of corn gives off about 3,000 to 4,000 gallons of water each day, and a large oak tree can transpire 4,000 gallons per year. So, hindi na po yung picture na yung plants is nabalutan na po ng plastic bag, and it shows that the inside of the bag becomes misty with transpired water vapor. Transpiration and groundwater. In many places, the top layer of the soil where plant roots are located is above the water table, and thus is often wet to some extent, but not totally saturated. As the soil is below the water table, the soil above the water table gets wet. When it rains, as water infiltrates into it from the surface, but it will dry out without additional precipitation. Since the water table is usually below the depth of the plant roots, the plants are dependent on the water supply by precipitation. As its diagram shows, in places where the water table is near the land surface, such as next to lakes and oceans, plant roots can penetrate into the saturated zone below the water table, allowing the plants to transpire water directly from the groundwater system. Here, transpiration of groundwater commonly results in a drawdown of the water table, much like the effect of a pump well. Because of depression, the dotted line surrounding the plant roots in the diagram. So here's the diagram of transpiration and groundwater. Lesson 6. Progress in understanding evaporation processes. Evaporation occurs as water changes physical states. Although it is explained as scientific processes, many examples of evaporation occur daily. Evaporation is the process of a substance in liquid form transitioning into the gas phase. For evaporation to occur, the liquid must gain enough energy to excite the molecules to move farther apart. Often, the energy comes from heat. Evaporation in the atmosphere. Water molecules are constantly cycled through our atmosphere. When rain falls, then dries up and eventually falls again. When the various sources of water on the planet dry, evaporation is occurring. The water molecules gain enough energy through the sun's light or heat radiating from the Earth's surface to turn into water vapor. Then, they release into the atmosphere in the gaseous state. Next is evaporation in daily life. Evaporation commonly occurs in everyday life. When you get out of the shower, the water on your body evaporates as you dry. If you leave a glass of water out, the water level will slowly decrease as the water evaporates. One important example of evaporation is sweating. The sweating requires energy to evaporate off of your skin. It gets that energy from the excess heat your body is producing, in turn, causing you to cool down. And that's all. Thank you.